Welcome back to Seacoast High School's remote trigonometry class. My name is Eric Fearing. I use he, him pronouns, and most of my students call me Mr. This is our third video about Competency 2 Benchmark 3. We're discussing today the law of cosines, and we're first going to use that to solve for missing angles in a acute or obtuse triangle. The law of cosines is c squared equals a squared plus b squared minus 2ab cosine z. I really like using the law of cosines because it reminds me so much of the Pythagorean theorem. We know that a squared plus b squared equals c squared. The law of cosines is just a variation on this where, okay, if we don't have a right triangle, we can't say that a squared plus b squared equals c squared like we have been for literally thousands of years, but there is a way to adjust it, and it's based on the cosine of the angle we care about. Now, usually we're talking about the hypotenuse in a right triangle for the Pythagorean theorem. In the law of cosines, it doesn't have to be the biggest angle, and the hypotenuse doesn't have to be a right angle, so technically there's nothing called the hypotenuse. The important point is that angle C is across from side C. So the angle we're talking about, the only angle that appears anywhere in the formula for the law of cosines, is the one across from the angle which we're setting as our total. And C can actually be really tiny, which is going to mean we're subtracting a big number from this stuff. And if C is very large, probably because we had an obtuse angle here, we're going to get a negative cosine value, so we actually add something to this. The idea of negative sine and cosine values is something that we're going to address more in the next competency, but to keep us sticking to just drawings of triangles for now, we're doing this a little bit out of the order I might present it if I were seeing y'all in person every day. So we've got c squared equals a squared plus b squared, and this correction factor based on whether c is actually a 90-degree angle or whether it's acute or obtuse. And I just think that's really slick. It does not matter what letters we use, of course. Sometimes textbooks especially will say that the law of cosines is actually 3 parts, where we switch the a and the c and just rewrite the same thing. So now instead of a and b here, we've got b times c, and the cosine of angle A. And then there's a version where we have b squared on one side and the cosine of b on the other, and the other parts are a and c minus 2a and c. But I think that's tremendously confusing and totally unnecessary. We can just think of it as c squared equals a squared plus b squared minus 2ab cosine c. And remember, this is a variation on Pythagorean theorem, where instead of a right angle for big C and the hypotenuse, little c, any angle pair and the side across from it will work just fine. So let's do a sample problem like what's going to be in your problem set. Here's triangle MJF. We have 3 sides that are all known to us. Now there are 4 variables in the law of cosines: C, A, B, and capital C. So if we want to find an angle, we have to know all 3 sides, which we do here. So we're not using A, B, and C, we're using M, J, and F. That's fine. Let's pick an angle to find. I'm going to go with M. So if I want to know angle M, I'm going to end up with the cosine of M at the end of my equation. And the rest of this I just need to plug in appropriately. So the measure of angle M is going to be across from side little m. 5 and our unknown variable are the important pair that's going to replace c and c. M is 5 squared. And now the rest we can fill in with our other 2 legs, 3 and 7. Now, 7 would be the closest thing to a hypotenuse because f is the largest side here, but we don't really care about that. The law of cosines works on any of the sides as long as you're finding the side across from the appropriate angle. So when we're finding m, we got to match side of 5 as our left-hand part of our equation. It's okay. So j and f are 3 and 7, and those are going to take our place of a and b. J and f, J and f, whereas here we had big M, little m. So 3 squared plus 7 squared minus 2 times 3 times 7. I'm going to do some of this without a calculator because this is a lot to type in. Let's see what we can do. 5 squared is 25. 3 squared is 9. 7 squared is 49. 2 times 3 is 6. 6 times 7 is 42. So we've got minus 42 cosine of m. Stop here and pace yourself. Too many times I've seen students say 49 minus 42 is 7. And while that might be true of the numbers, this isn't just 42. This is 42 times an unknown cosine. This is a variable term. So we can move the other numbers around, but we need to get the variable term, the whole correction factor, by itself first. I can add 49 plus 9 and get 58. And then I can take 58 away from both sides of my equal sign. 25, take away 58. It's going to be negative 33, I think. I'll double check that in a second. Equals negative 42 times the cosine of m. Negative 42 is the coefficient on our cosine. So we're going to divide by that coefficient, negative 42. And that'll tell us the exact cosine of angle m. And we can use an inverse cosine to work our way back to what the angle itself is. So we need a calculator. Desmos.com Scientific comes on back. I'm not feeling particularly confident today in my ability to subtract, so I'm just going to double check. 25 minus 58 is negative 33, thank goodness. And when we divide negative 33 by negative 42, we get a gross decimal. It is a positive number, so 33 over 42. And now to find angle m, we're going to take the inverse cosine of both sides. So cosine inverse of 33 over 42 is going to be m, which will be approximately equal to what we get out as a decimal when we keep that in here. To get an inverse function, we hit the function button, the inverse cosine, back to the main tab, and I'm going to input our answer, which is going to be as precise as possible. So the inverse cosine of 33/42 is approximately 38.2 degrees because we're in degree mode. So when we're going through a problem with the law of cosines and we need to find an angle, we have to know all 3 sides of the triangle because the only variable would be the angle itself. When you're collecting terms, make sure that you don't accidentally combine the coefficient on the cosine with the other 2 numbers. Expect that you're going to be dividing by the coefficient on cosine to get a fraction before you take your inverse cosine. This is certainly the step that's the most difficult to remember when you get in the flow of something. It's just too easy to accidentally subtract when they're actually unlike terms, because 49 is just a number and 42 is the coefficient on that unknown. So this was our 3rd video about the Competency 2 Benchmark 3, where we found an angle using the law of cosines when we knew all three sides of an acute or obtuse triangle. Good luck with the problem set. You can always contact me during office hours or on Google Voice or Google Classroom and email.